All right, and here we are with factoring trinomials where a is not equal to 1. With me, Mr. Hain. And our essential question connects back to our previous video and our previous lesson. How does factoring trinomials where a equals 1 help us factor trinomials where a is not equal to 1? All right, let's dive right in. Okay, so I'm going to take a very slow and measured approach to example number 1. I want to make sure that we're actually understanding each step that I do. So, for example 1, 3x squared minus 20x plus 28. The first thing I do is I'm going to recall that using the x method, the top number is a times c. And unlike our last video, our a's in this entire section are going to be not equal to 1. In fact, for example 1, our a is equal to 3. So a times c, so 3 times 28 is our top number. And our bottom number is negative 20. All right, so a times c is 84. And once I have that, I'm going to use my t-chart and list out all of the numbers that when they multiply them together equal 84. And what I'm looking at is the ones that add up to 20. And the bottom two, 6 and 14, they add to negative 20 if both of those are negative. All right, so that just means that I can now have two negative numbers, negative 6 and negative 14. They multiply to 84, and they add up to negative 20. Cool. So this allows me to take my original problem and expand the middle term. So that negative 20x now becomes two separate terms, negative 6x and negative 14x. And that's where you see the two numbers here from the x pop into play. Awesome. Now that I have these two numbers, what I'm going to do is factor by grouping. So remember that when I factor with a negative, it changes the second term. And so this currently is a negative, but you'll see that as soon as I take it up to where it's grouped, it currently is a positive and now it becomes a negative. Awesome. Now I'm looking at the first group. What can I factor out of the first group? A 3x. Out of the second group, what can I factor? A 14. So when I do that, my two binomial terms are now x minus 2. They are the same, so I know I am on the right track. I can factor that to x squared times 3x minus 14. Kaboom! All right. That's how you factor where a is not equal to 1, by expanding the middle term and then factoring by grouping. All right, so go ahead and rewatch that section of the video. I know I went a little bit fast, even though I was trying to describe every step along the way, and do checkpoint 1 just like I did example 1. Pause the video. I'll be here when you get back. Okay, so for example 2 and example 3, you're going to see me do two more examples that factor by grouping. So for example 2, a times c, that's 8 times negative 3, is negative 24. And again, I'm looking for terms in this list that can add up to negative 10. All right, so there are two numbers that work. But in order to get negative 10, 4 and 6 both have to be negative. And a negative times a negative is a positive 24. So those cannot work. So the numbers that I'm going to choose is 2 and negative 12. And by using 2 and negative 12, one of them is negative. That's the negative 12. That's what multiplies to a negative 24, but adds up to a negative 10. And remember, now that I have these two terms, I can expand the middle term of my equation, or my expression here, the negative 10x. So now it's net plus 2x minus 12x. And then I can factor by grouping. Again, when I factor with a negative on the outside of the third term, it changes the sign of my fourth term. Now what can I factor out of that first group? I can factor a 2x. And out of the second group, I can factor a 3. And when I do, I see that my two binomial terms are identical. I have a 4x plus 1. Factor that 4x plus 1 to the front, and I have 4x plus 1 times quantity 2x minus 3. Kaboom! I'm done with example 2. So I'm going to take another look at example 3. So that way you can have two examples on the screen at the same time when you work out checkpoint 2 and checkpoint 3. So a times c is 2 times negative 6. That's negative 12. And I need that to equal a negative 1. And the only numbers that could work for that would be 3 and 4. And in order for those to be adding up to a negative 1, that 4 must be negative. And again, the 3 and that negative 4 allow me to expand my middle term and rewrite my problem so I have plus 3x minus 4x. Sweet. Factor by grouping. Notice again that the fourth term changes signs when the third term is negative. Looking at the first group, I can factor out an x squared, and looking at the second group, I can factor out a 2. Kaboom! My two binomial terms are the same. That means I'm on the right track. I can factor that to the front. I've got 2x minus 3 times x minus 2. Sweet. 2 more examples. Go ahead and pause the video and do checkpoint 2 and checkpoint 3 the same way I did example 2 and example 3. Pause the video. I'll be here when you get back. All right, let's take a look at example 4. So for example 4, it might be a little bit different because you see I have an a times c that's positive, but I need that to equal a negative b. All right, cool. So once I have that here, I'm going to look down the list, and the only numbers that add to 22 are 2 and 20. And if both of them are negative, they multiply to positive 40, but they add up to negative 22. And that's where I'm going to go. Now I can expand my middle term, so I have 8x squared minus 2x minus 20x plus 5, and group and factor. And again, when that third term is negative, it changes the sign of the fourth term when I factor by grouping. And out of that first group, I can factor a 2x. And out of the second group, I can factor a 5. And you notice that my two binomial terms are the same, 4x minus 1. I know I'm on the right track. Pull that 4x minus 1 up to the front. 4x minus 1 times 2x minus 5. And I'm done. Go ahead and do checkpoint 4 the same way that I did example 4. Pause the video and I'll be here when you get back. All right, so now you're looking at example 5 and you're going like, dude, 1, I don't like you because there's a variable for each term. And 2, I just don't like you because there's a variable for each term. So we're going to factor this completely. So by looking at 15y to the fourth plus 26y to the third plus 7y to the second power, I know that I can factor out a y squared. And now, if I see the quantity I have, 15y squared plus 26y plus 7, that is a trinomial where a is not equal to 1. So I'm going to go ahead and take a times c. It gives me 105. Only one of these factor pairs add up to 26, and that's the 5 and the 21. Boom. So that means I use the 5 and the 21. They're both positive. Expand that middle term and group them. Now I don't have to worry because the third term is already positive, so I don't have to change any signs. And I can factor out a 5y from the first group, and I can factor out a 7 from the second group. And that gives me 5y, the two binomial terms that are the same. That's 3y plus 1. So I can pull that 3y plus 1 up to the front, and I can factor right like that. 3y plus 1 times 5y plus 7. But wait, there's more. Remember that we factor out this y squared all the way at the beginning. So I'm going to bring that down. So my factored form. So now that I have that, I have all three terms for my factored trinomial when I factor completely. That's my answer. Go ahead and use the same method and factor checkpoint 5 the same way I factored example 5. Pause the video. I'll be here when you get back. Till next time, people, keep doing the math.